Hello everyone, welcome back to my channel. So let's start today's lecture. Up till now what we did is we found the ways of solving quadratic equations and we did different methods, factorization, completing the squares and by using quadratic formula. Now we are moving forward and we are now studying about solving simultaneous equations of one linear and one quadratic. So it means we'll solve two equations together. Up till now what we did is, so if we have a quadratic equation, let's say ax square plus bx plus of c is equal to 0. So if this is a quadratic equation, we found those particular values of x for which the complete equation is becoming 0. So for x is equal to p and x is equal to q, let's say these are the two values of x for which this complete equation is becoming 0. So we were identifying these 2 points, right? We are identifying 2 points, two values of x for which the quadratic equation is becoming 0. Now what we are saying that we need to find solution between two equations, one linear, one quadratic. So first of all, we need to move to two dimension. So if we have this as x-axis and we have this as y-axis, so if we write a quadratic equation, y is equal to ax square plus bx plus c, what does this gives us? This equation tells us that if we take any value of x, let's say x is equal to p, if we are taking this value for x, we'll substitute this in equation and whatever result we are getting, that particular result, let's say it k, that we'll take for y. So our coordinates will become, if this is p and this is y, so this this is k in y and this is x, so we'll get this particular coordinate, right? This is a two dimension. Now in a quadratic equation we get a parabolic curve, and if we are talking about linear equation we get a straight line, right? If I give you an example, so if I take a quadratic equation over here, so x square plus 3x and plus of 5, or let's take 4. So this is a quadratic equation and we say that uh, y is equal to x square plus 3x plus 4. So this equation we're getting, so this is a quadratic equation, right? uh, it's just like a parabola, so it's a parabolic curve. And um, normally what we did up till now was, so if we were talking about a quadratic equation, so y is equal to x square plus 3x plus of 5. So if this was a quadratic equation, we took one more equation, y is equal to 0, and we substituted over here, we got x square plus 3x plus 5 is equal to 0. For example, if I tell you over here, let's take it as negative of 4. So negative of 4. So now this is one quadratic equation and I take one more equation, that is y is equal to 0, right? So this is the second equation we are taking, linear. Both of these equations give us a result that is the intersecting point of these two lines. These are the two intersecting points. So x is equal to -4 and x is equal to 1 are the two zeros or solution of this quadratic equation when y is 0. So this was what we were doing up till now. We are taking a quadratic equation. So quadratic equation, function of y is equal to f of x, where function is a quadratic equation, this. And we were saying that those points of x when y is 0. So we got those particular points of x. But now there is a slight change. Now what we are saying that we'll take a quadratic equation and we'll also take a linear equation. So y is equal to x square plus 3x minus a 4, one quadratic equation, and we say y is equal to, let's say, 5x, right? So these are the two equations. One is quadratic, one is linear. Now instead of 0, y is equal to 0, we are taking a different equation. So we'll try to find those particular points which are the intersecting points of y is equal to x square plus 3x minus 4, a quadratic equation, and y is equal to 5x, that is a linear equation. So to find those intersecting points, if I take over here y is equal to 5x. Now if I look closely, these are the two intersecting points. One is over here, right? And this is one point. This is one intersecting point. And if we go, if we move forward, one intersecting point is over here. This is second intersecting point. So these are the two intersecting points, right? So if we are talking about solution, these points are the solution. Solutions are two coordinates of x and y. These are 2 points at which earlier what we were taking x-axis. Now we are changing it to a linear equation. So these are the 2 points at which the linear equation and quadratic equation intersect each other. So these are the two solutions of linear and simultaneous solutions of linear and quadratic equation. I hope the topic is clear, and I hope what we are finding that is also clear. Before, we were finding just the intersecting points on x-axis, right? These 2 points, these were the solution points. Now we are finding intersecting points of the quadratic equation, the parabola, with any given line, right? Not just the x-axis. So any given line, y is equal to any linear equation. All right. I hope I made it clear, and let's continue. So this will be our main idea in this topic. All right. So we'll solve two simultaneous equations. Simultaneous equations means same x and y for both the equations. One is linear, the degree will be 1, and other will be quadratic, the degree will be 2. Let's move forward. Now, this was what we will do. Now I will explain how we will do that. So over here we are having one equation is y is equal to 6 minus x. Second equation is y is equal to x square. Let's check it in the graph. One is y is equal to x square and y is equal to 6 minus x. So we have y is equal to x square and y is equal to 6 minus of x. So these are the two intersecting points of the given quadratic equation and given linear equation. So these are the two solution points. right? The quadratic equation forms a parabola, linear equation goes straight, they cut at 2 points. So these points should be the solution. Now, this is graphically. Graphically is very easy, but how we'll solve it if we don't have graph? Now, what we'll do is we'll take one equation, equation number one, and we'll substitute that in second equation. So we have value for y, both the y's. So we'll take equation 1 in equation 2. We are substituting equation 1 in equation 2. We substitute these. In place of y, we can write 6 minus x is equal to x square. Okay, so we can get a quadratic equation over here, x square plus of x minus 6 is equal to 0. So from here we can find those points of x which satisfy these equations, right? Those particular intersecting points will satisfy both the equations. So this quadratic equation will give us those 2 points. So if I simplify it, so using quadratic formula, or if I say by factorization also, it's easy. So x square and um, product over here is -6, sum is 1, that is plus of 3 and minus plus 3x minus 2x minus of 6 is equal to 0. X plus of 3 and minus 2 x plus of 3 is equal to 0. So x plus of 3 and x minus 2 is equal to 0. These are the two factors. So value of x is -3 or value of x is 2. We got the values of x. Substituting these values in equation number 1, y is equal to 6 minus x. Y is equal to 6 minus x. We can find the values of y. So y is equal to 6 minus of minus 3, and over here we get y is equal to 6 minus of 2. So y is equal to minus of minus 3 is plus of 3, 6 plus 3 is 9, and we get y is equal to 6 minus 2, that is 4. So these are the two values of y for these particular x's. So coordinate that we are talking about, which is the solution for these two equations, will be when x is 3, -3, and y is 9, and when x is equal to 2 and y is 4. So these are the two solutions. If I check, -3 and 9, 2 and 4, that's correct, right? So I hope you understood what we are mainly talking about and what we want to do over here. We will find intersecting points of quadratic equation and linear equation. So quadratic equation is like a parabola and linear equation is a straight line. So intersecting points. So solution of two simultaneous equation is intersecting points of those two lines. So that is what we are finding. Let's proceed. Okay. Question number 2. So we have linear equation, equation 1, quadratic equation, equation 2. Now these are these are not in very simplified form, so we need to find the solution for these. Let's try. So if I take from equation 1, I can write x plus 4y is equal to 6. So from here I can write 4y is equal to 6 minus x, and I can also simplify it and write it as y is equal to 6 minus x by 4, right? So this is what I am getting for equation number 1. Let's say it as equation number 3. Now substituting equation 3, substituting equation 3 in equation 2, right? If I substitute this over here in this given y, what I'm doing is I'm finding value of one variable from one equation and substituting that in the other equation, because both the values of x and y will be same for that particular 2 points of intersection, right? I'll substitute this in the quadratic equation, that is x square plus 2x times 6 minus x over 4 is equal to 8. So this is what I'm getting, right? So let's simplify it. What I get is x square plus of, now this will get divided, we get x times 6 minus x by 2 is equal to 8. Taking LCM, we get 2x square plus x times 6 minus of x is equal to 8 to the 16. I'm taking to the other side, and if I simplified x 2x square plus, if I multiply this, 6x minus x square is equal to 16. Simplifying it, 2x square minus x square plus 6x minus 16 is equal to 0, right? So I can also factorize this. X square plus 8x minus 2x minus 16 is equal to 0. X plus of 8 minus 2 x plus of 8 is equal to 0. X plus of 8 x minus of 2 is equal to 0. From here I get x is equal to negative 8 and x is equal to 2. These are the two values of x. X is equal to negative 8 and x is equal to 2. Now if I substitute these values in equation number 3, that is simplified equation of equation number 1. So if I substitute these values in equation number 3, what I will get is, if I substitute x is equal to negative 8 over here, I get y is equal to minus 6, sorry, not minus 6, y is equal to 6 minus of minus 8 by 4. That is 6 plus of 8. That gives us 14 by 4. That is 7 by 2. That is 3.5. This is why for x is equal to 8. And if I substitute x is equal to 2, what I will get is y is equal to 6 minus of 2 by 4. That is 4 upon 4. That is 1. So the two coordinates that we are finding, which are our solution, is when x is negative 8, y is 3.5, and when x is 2, y is 1. So these are our two solutions. Okay, let's move forward. All right, so 3x is equal to x plus 10. This is 3y is equal to x plus 10 is our first equation, and x square plus y square is equal to 100. This is our second equation. From first equation, what we can do is we can find the value for y. So from equation number 1, we can say y is equal to x plus 10 by 3. This is our first equation, and we can mark it as equation number 3. So from first we found this, we can substitute equation number 3 in equation number 2. So if we substitute this equation number 3 in equation number 2, what we get is x square plus x plus 10 by 3 whole square is equal to 100. All right, we'll open this whole square. We get x square plus 100 plus 2x by 3 times 3, that is 9, is equal to 100. So if we take LCM over here, we get 9x square plus x square plus 2x plus 100 is equal to, we take 9 to the other side, we get 900. Now we get 10x square plus 20x 20x plus 100 is equal to 900. We take 10 common and we'll divide it. 2x plus 10 is equal to 900 by 10, that is 90. We'll bring this to the left hand side, we get x square plus 2x plus 10 minus 90 is equal to 0. That gives us x square plus 2x minus 80 is equal to 0, right? So we get this, and we can simplify it. We can find the zeros of this quadratic equation, that is x is equal to minus of 2 plus minus root of square of 2, that is 4, and minus 4ac, 4a, that is 1, and c, that is minus 80, by we get 2a, that is 2. So that gives us negative 2 plus minus of, we get 8 for the 320, 324. So this is what we are getting, and divided by 2. So if we want to find what is the square root of 324, this is actually 18, right? So we get x is equal to negative 2 plus minus 18 by 2. That will give us x is either negative 2 plus 18 by 2, or x is equal to negative 2 minus 18 by 2. So from here we get x is equal to, we subtract it, we get 16 by 2, and we get x is equal to negative 20 by 2. That gives us x is equal to 8, or x is equal to negative 10. We get the two values for x. We can substitute these values in equation number 3, and we can find the answers for y. So if we substitute these values in equation number 3, we get y, if x is equal to 8, y is equal to 8 plus 10 by 3. So y is equal to 18 by 3, that is 6. And if x is equal to negative 10, we substitute this, y is equal to negative 10 plus 10 by 3, and we can find the answer, and we get y is equal to 0. So two coordinates are 8 comma 6, and second coordinate is negative 10 comma 0. So these are the two coordinates, and these are the two solutions of the linear and quadratic equation. If we check this in graph, so 3y is equal to x plus 10, and x square plus y square is equal to 100. So this is first point, negative 10 comma 0, and this is second point, which is 8 comma 6, right? So that is our answers. So okay, part number D, we'll substitute this in equation number 2. So equation number 1, equation number 2, substituting equation 1 in equation 2, we get 8x square minus 2x, and in place of y we can write 3x minus of 1 is equal to 4. We get 8x square and negative 6x square, negative negative positive 2x is equal to 4. This gives us 2x square plus 2x minus 4 is equal to 0. We can take 2 common over here, we get x square plus x minus 2 is equal to 0. So this is the quadratic equation that we are getting, and if we simplify it, we can write it as x square plus 2x minus x minus 2 is equal to 0. So x plus of 2 and minus 1 x plus of 2 is equal to 0. X plus of 2 and x minus 1 is equal to 0. We get x is equal to negative 2, or x is equal to 1. So these are the two values of x that we are getting, You can substitute this in equation number 1, that is y is equal to 3x minus 1, and we can get our values of y. Y is equal to 3x minus 1. Substitute these values of x over here, we get y is equal to 3 times negative 2 minus of 1, that gives us negative 6 minus 1, that is negative 7. And if we substitute, this is for x is equal to negative 2, and if we check for x is equal to 1, we get y is equal to 3 times 1 minus of 1, that is 3 minus 1 2. So our coordinates for the solution are negative 2 comma negative 7 and 1 comma 2. So these are our answers. Let's move to the next question. We'll again simplify it. We can find any value for equation number 1 or any value for the any variable. So equation number 1 we get this, equation 2 is this. So from equation 1 we can say 2y is equal to x minus of 6, taking 2y to the right hand side and 6 to the left hand side, and y is equal to x minus 6 by 2. We can say it as equation number 3. Why I always try and find value for y, because substitution of y in second equation is easy. If we find out value for x, we need to substitute it in two places. That will be a bit longer. So substituting y is a bit easier. So substituting equation 3 in equation 2, we get if we substitute these, we get x square minus of 4x times x minus 6 by 2 and is equal to 20. So we substituted this and we got x square minus 4x times x minus 6 by 2 is equal to 20. To simplify it, we get x square minus 2x times x minus of 6, just divided 4 and 2, we got 20 over here. So x square minus 2x square minus minus plus 12x is equal to 20. We get negative x square plus 12x is equal to 20. Taking left hand side to the right hand side, we get 0 is equal to x square minus 12x plus of 20. That gives us the quadratic equation x square minus 12x and plus of 20 is equal to 0. So this is the quadratic equation. Values of x from this quadratic equation will give us the solution, values of x in the values of x of the intersecting point in the solutions. So we'll try and simplify it. X square minus 10x minus 2x are the factors, and plus 220 is equal to 0. So we split this middle term negative 12x to negative 10 negative 2. Taking x common, x minus of 10 minus 2 common, x minus of 10 is equal to 0. So we get x minus of 10 and x minus of 2 is equal to 0. From here we get x is equal to 10 and x is equal to 2 as our 2 points of x of the solution. So substituting these 2 points in equation number 3, we can find the values for y as well. So if I take x is equal to 10 and if I substitute it, I will get y is equal to 10 minus 6 by 2, and that is y is equal to 4 by 2 and y is equal to 2. And if I take x is equal to 2 and substitute this in equation 3, what I will get, y is equal to 10 minus not sorry 10, it is 2 minus 6 by 2. So I get y is equal to negative 4 by 2, and that gives us result that is y is equal to negative 2. So the coordinates of intersecting points are 10 comma 2 and 2 comma negative 2. So these are our answers. All right, let's continue. So we have two equations, one equation 2, and we find value of y from equation number 1. So from equation 1, what I'll try to find the value of y from here. So I get 3y is equal to 4x minus a 5, and y is equal to 4x minus 5 by 3. So let's mark it as equation number 3, and I will substitute this equation 3 in equation number 2. So substituting equation 3 in equation 2, so we substitute this, we get x square plus of 3x times 4x minus 5 by 3 is equal to 10. So substituting this, I get x square plus x times 4x minus of 5 is equal to 10. So this is what we are getting. And if we simplify it, we get x square plus 4x square minus 5x is equal to 10. And we get 5x square minus 5x minus 10 is equal to 0. Taking 5 common, x square minus of x minus 2 is equal to 0. Taking 5 common and taking it to the right hand side will just cancel this 5. This is what we are getting. We can write it as x square negative 2x plus of x minus 2 is equal to 0. Taking x common, x minus of 2, and taking 1 common, x minus of 2 is equal to 0. X minus 2 and x plus of 1 is equal to 0. So the two points of x, two coordinates of x are x is equal to 2 and x is equal to negative 1. So we substitute these two values of x in equation number 3. What we get is the points of y. So if I take x is equal to 2, I substitute it equation number 3. What I get, y is equal to 4 to the 8 minus 5 by 3, that is 3 by 3, that is 1. And if I take x is equal to negative 1 and substitute it over here, I get y is equal to 4 minus of 1 minus 5 by 3, that is y is equal to 9 by 3, and also negative gives us negative 3. So the two coordinates that we are getting are 2 and 1, and the second one is negative 1 and negative 3. So these are the two solutions of the linear equation and quadratic equation. Let's move further. All right, so equation number 1, equation number 2. Now this equation number 2, we have something multiplication over here, right? So we'll not try to simplify this. What we'll do, we'll just take the value of y from equation number 1. So from equation 1, what we get is y is equal to 8 minus 2x, right? So we get this from equation number 1. We substitute it in equation number 2. Let's mark it as equation 3. So substituting 3 in equation number 2. If we substitute this, what we get, x times 8 minus 2x is equal to 8. We get 8x minus 2x square is equal to 8. So if we simplify it a bit, we get 2x square minus 8x and plus of 8 is equal to 0. and taking 2 common, we get x square minus 4x plus of 4 is equal to 0. So we can factorize it: x square negative 2x plus of 4 is equal to 0. Taking x common, x minus of 2 and negative 2 common, x minus of 2 is equal to 0. We get x minus 2 and x minus 2 as two zeros of this quadratic equation, and two factors of this quadratic equation, and zeros are x is equal to 2 and 2. So these are the two values of x. Substituting these two values of x in equation number 3, what we get is, so we substitute it in equation number 3, we get y for x is equal to y is equal to 8 minus 2 times 2, that is 8 minus of 4, we get 4. So the solution are 2 comma 4 and 2 comma 4. So only one point is the solution. The curve is just the uh, linear line is just touching and passing through the quadratic equation. So I can show you this in graph. So we have 2x plus y is equal to 8. So if I write over here 2x plus y is equal to 8, and in second equation if I write, the second equation was xy is equal to 8. So xy is equal to 8. So this is what we are getting. So this point, right, 2 comma 4, this is our point of solution. Curve is just touching and passing. This is a point of tangent. All right, I hope it is clear, this particular point, right? So 2 comma 4, this is the only solution. Let's move to the next question. All right, so from here I can find value of y, equation number 1, equation number 2. So 2y minus x is equal to 5. So this is from equation number 1, and 2y is equal to 5 minus 5 plus x. Y is equal to 5 plus x by 2. So this is the value of y. Let's mark it as equation number 3. We'll substitute this equation 3 in equation number 2. So we substitute this, we get 2x square minus 3, and in place of y we'll write 5 plus x by 2 square is equal to 5, not 5, 15. So this is what we get after substitution. We'll simplify this, we get 2x square minus 3, and let's bring this 2 outside, so square of 2 is 4, and we are left with 5 plus x whole square is equal to 15. 2x square minus 3 by 4, so we get 25 plus x square plus 10x is equal to 15. We'll take LCM over here, we get 8x square minus 3 times x square plus 10x plus 25 is equal to 4 goes to the other side, get multiplied with 15 and gives us 60. We'll open this bracket, we get 8x square minus 3x square and minus of 30x and minus of 75 is equal to 60. We get 5x square minus 30x minus 75 minus 60 is equal to 0. So from here we get 5x square minus 30x and minus of 135 is equal to 0. We'll take 5 common, we get x square minus 6x and minus of 27 is equal to 0. So if I see, we can factorize this by 9 and 3 x square minus 9x plus 3x minus 27 is equal to 0. So x minus 9 and plus of 3 x minus 9 is equal to 0. We get x minus of 9 and x plus of 3 is equal to 0. So the two values of x are x is equal to 9 and x is equal to minus 3. These are the two values of x. If we substitute these values in equation number 3, we get the values of y. Those are, for x is equal to 9, we get y is equal to 5 plus 9 by 2, that is y is equal to 14 by 2, that is 7. And for x is equal to negative 3, we get y is equal to 5 minus 3 by 2, that is y is equal to 2 by 2, that is 1. So the coordinates are 9 comma 7 and negative 3 comma 1. So these are the two solutions of um, simultaneous solution of linear and quadratic equations. Let's move further. I hope it is clear. All right, we'll try and find a value of, now see, we have x square, y square, xy. We can take value of any variable, that is one the same thing. So equation number 1, equation number 2, we can take value of x from here. We get 6 minus 2y, and if we substitute this, let's mark it as equation 3. So if we substitute 3 and 2, we get 6 minus 2y whole square plus y square plus 4 times 6 minus 2y and times y is equal to 24. So squaring this, we get 36 plus 4y square minus of 24y plus y square, and over here if we simplify this, we get plus of 24y and minus of 8y square is equal to 24. All right, let's bring y squares to the one side, and we get 4y square plus y square minus 8y square and plus of 24y and minus of 24y and plus of 36 minus of 24 is equal to 0. From here we get minus 3y square and plus of 12 is equal to 0. That gives us y square minus of 4 is equal to 0. That is y square is equal to 4, y is equal to plus minus of 2. We get two values of y. We can substitute that in equation number 3 and we can get values of x. So if we substitute these two values of y in this equation number 3, we get x is equal to, for y is equal to 2, we get x is equal to 6 minus 2 times 2, that is 6 minus of 4, that is 2. And for y is equal to negative 2, we get x is equal to 6 minus 2 times negative 2, that is 6 plus of 4, that is 10. And so this is the value of x. So coordinates are 2 comma 2 and over here 10 comma negative 2. We always write coordinate of x first. All right, I hope it is clear. Okay, so I think that's enough for today. We'll continue rest of the questions in the next lecture. All right. Thank you. Thanks for joining.